Hey everyone, welcome back to Swift Fundamentals. Today we're diving into parameters and the self keyword. We'll cover how parameters work in functions, what self does, and how to set default values. At the end, we'll also touch a little bit on .self and capital self. That's right, there's three kind of types of selves. That's a lot of them. But let's go ahead and dive on in. I have a blank playground open, so if you want to open one, you can just go to the Xcode option, File, New Playground, and then choose a template, and then you can kind of just delete everything to get started. So I'm going to create a structure for a person. I'm going to add some properties like name and age. This will help us see self in action and work with parameters directly. So I'm going to clear my struct by just typing out struct, and then we'll go ahead and give it a name. When you are creating a structure, you can start that with a capital. We'll add a brace here. I'm going to add two variables. The first one's going to be name. We'll say that this will be a string value. So we're going to say var name colon. We're going to do the exact same thing for age. And this time we'll say that it's going to be an integer, so a whole number. So this person struct has two properties, name and age. Now let's add a function to introduce the person. So to create that function, we're going to add an introduce function inside the person struct. So this is going to take a parameter to show you how parameters work in functions. So go ahead and declare this. We're going to say func introduce. And normally when we create a function, we kind of just add these two brackets and a brace and we move on. But actually within these brackets is where we put the parameters. So we're going to create a parameter here and we're going to say greeting. We're going to say string. And now every time we call upon this function, we need to pass along a string of greeting. So let's go ahead and now print out here, and we'll say interpolate the greeting, comma, and then we'll say let's go ahead and interpolate the name. So to do that interpolation, you'll just do that / brackets, and then that variable or value within those brackets. And go ahead and interpolate our age, years old. So here the introduce function has a greeting parameter, letting us pass in any greeting when we call the function. Notice we're using name and age directly in the print statement. Swift knows to access the name and age properties of this instance of person. Now let's talk about lowercase self. Self is used when there's a name conflict or when you want to be clear about which property or method you are referencing. Here's how we can use self to introduce our method. So what we can do is in our interpolation here, we can say self.name and self.age. And using self name and self age, explicit refers to those properties of the current instance. This can help when you have a parameter with the same name as a property. So let's go ahead and say a case where self becomes essential. Suppose we add another function called update name that has a parameter also called name. Now we'll need self to clarify which name refers to the property and which is the parameter. So let's go ahead and create a new function. So something you're going to notice as I create these functions is I'm going to be calling it a mutating function. And so there's kind of like a mutating and immutating. So when we have something that's mutable or mutating, it's kind of like a variable. It can change, whereas immutable, it's more like a constant. It can't really change or update. So let's go ahead and call this update name. And we're going to create another name here within our parameter, and we're going to say that it's a string. And let's go ahead and have self.name equals name. So the self.name refers to the property, whereas name refers to the parameter. Here, self.name refers to the name property of person, while name without self refers to the parameter passed in. This distinction prevents any confusion. Swift also allows us to add default values for parameters, which makes functions more flexible. Let's add a new greet method that has a default value for greeting. So I'm going to make some space here, and I'm going to create a new function, and we'll just call it greet. We'll say greeting. We'll say that's going to be a string. We can actually give it a value here, so it's going to be that default value, and we'll just maybe say hello. Let's add our brace here, and we can say print. We can interpolate that greeting here. And we'll say I'm, and we'll interpolate that name from the structure. With greeting, if we don't pass along a greeting when calling greet, Swift will use that hello by default. Now we can greet with or without the custom greeting. So let's go ahead and test everything out. Let's create an instance of person and test our functions to see everything in action. So I'm going to go ahead and leave this structure here. I'm going to kind of clean it up just a little bit. I'm going to create a variable called person here. Person, let's have that equal person. And you'll notice that when we are calling upon our structure here, we can use the autofill feature here. We can see what we are required to have, which is that name string and age integer. We're just getting some errors because it's on auto run. Don't worry about that. So let's go ahead and have our name be Alice, and we'll give it a age number of maybe 25. You can of course put anything in the world you'd like to have in there. So let's go ahead and do person. And if we do the dot here, we can actually see all of the properties as well as all of the methods or functions that are associated. And you'll even notice, we'll get to this in a bit, but you can see our greet has two options here. One where we actually don't pass along anything, so that would actually give us that default hello value, and one where we're going to be passing along a greeting of string. So I just wanted to make you aware of that because I think it's pretty cool. So let's go ahead and select our introduce here. And we can say, hi, whatever you'd like, but this should output, hi, I'm Alice, I'm 25 years old, and we can see in the console it absolutely does. We can also update the name, as we do have that function as well. That's our mutating function. So we can say person.update name. And let's go ahead and update this to be Bob, or whatever name you want to update it to. And then let's go ahead and print the person dot name, and that should now print Bob in the console, which it does. So if we go ahead and now greet, let's do a greet without passing the parameter so we can see the default. So I'm going to do person dot greet. So this first one here, it should say, hello, I'm Bob. It absolutely does. And now if we change the greeting, so if we do person dot greeting and we pass along a string, let's go ahead and change this to be, hey, what's up? I'll say, hey, what's up? I'm Bob. Although my grammar is a little bit off because there's a comma, but still pretty good. So here we created a person instance called introduce with a custom greeting, updated the name using update name, and tried the greet function with and without a custom greeting. Finally, let's take a look at dot self and capital self, two terms that add even more flexibility in Swift. So dot self refers to the type itself as a value, not an instance. Here, let's create an example where we store the type as a value. So let's create a new constant here. We'll say let type of person equal person dot self. Using dot self here, we refer to person as a type, not an instance. Let's go ahead and actually print out that type of person. It's going to put person in the console there. So capital self refers to the type of a struct, class, or protocol. I typically are using these in protocols to enforce that a type is the same as the conforming type. So I'm going to create a protocol here, and we'll say identifiable at our brace here, and then we can say static function identify, and then we'll return as self with a capital S. So in this protocol, self refers to the conforming type, helping us enforce the same type when implementing the function. So let's recap. Today we covered parameters, self with a lowercase, dot self, and capital self. Parameters let us pass the data into function. Lowercase self helps us reference instance properties. Dot self is the type itself, and capital self refers to the type in protocols. These tools make Swift code organized and clear. The three different uses of cells can kind of be a little bit confusing, but just to kind of wrap it up in a nutshell for those, the lowercase self keyword, this distinguishes instance properties from parameters. Dot self refers to the type as a value, and that capital self refers to the conforming type in protocols. Unless you're dealing a lot with protocols, you won't really necessarily have to use that capital self, but good to know. And then of course, yeah, those parameters and functions. So what do we have within these brackets here? That's how we can pass values into functions for flexibility. You might have even used them when you're doing something with a function to do with math, you know, number 1, number 2, right? You pass along those two numbers in those brackets in order to, you know, give that information to the function. Really, really essential. And it's also cool that with our greeting here, we can also provide that default. So greeting string equals hello. So even if we don't pass along things, we can kind of have those defaults or those fallbacks for a custom message or a non-custom message. So that's it for today. I hope you learned lots about parameters and self. I was going to make a joke about you learned so much about yourself, but then I didn't want to introduce another self to confuse people. Anyways, take care.